Hello, and welcome to Showing Where to Look's first Why Not More Math Wednesdays post. On Wednesdays, we'll be covering more in-depth or advanced topics and applications of math. Today's topic is the real number system. This is something that a lot of pre-algebra students have a little bit of trouble grasping and getting a hold of the vocabulary involved. So there are two kinds of numbers. Real numbers are numbers that you can point to a number line, say this is 0, this is 1, and you can say, well, this number is right about here. So there's something that is tangible. There's also something called imaginary numbers, but those are something you'll get in Algebra 2, so that'll be a topic for a different day. So real numbers, let me make a chart here. Oops. Making sure we can see it. All right, real numbers. The two main groups in the real number system, the two main sets, are rational and irrational numbers. So on this half of the board, we will make a box for, let me make sure that's, yes, okay, for rational numbers. I'll abbreviate that there. And then on this side of the board, let's make a box for irrational numbers. Now, rational, we know that word as making sense, right? But rational also comes from the word ratio. So if you recall, a ratio is when you can put two numbers into a fraction. So 3 over 4, that's a ratio of 3 to 4. So any number that can be rewritten or is already a fraction is a rational number. Okay? Irrational numbers are numbers that can't be written as a fraction. Again, irrational can't be made sense of or doesn't make sense. So numbers are real, but they're not as easy for our brains to make sense out of or for us to do math with. So irrational numbers are pi is 1. The square root of 2 is another. Basically, irrational numbers are those decimals that go on infinitely, forever, with no pattern to them whatsoever. So, negative 3.468729016 ... forever and ever, that's an irrational number. So, again, they're hard to do math with. Pi we can do math with just because we can leave it as pi. Square root of 2, we can do math with that and leave it as square root of 2. Or we can round these numbers, and we would have to round this in order to make it something that we can work with rationally that would make sense to us. Okay, so in our rational numbers group, there are subgroups within here. So a set of rational numbers, I'm going to draw this box inside here because all of these are going to be rationals. Actually, let me make that a little shorter so I have room. There we go. So these would be your integers. And remember, this could be things like 3/4, or even 2 over 1. right? But I'm going to leave that out because that actually goes in a different subgroup in here. All right, so integers are, the negatives and the whole numbers. So these would be like -3, 0 actually goes in a different group. How about we do this way? -3, 0, 2, 4, -6. Those are all integers. Okay, they're these whole numbers and their opposites, the negatives, and it includes 0. Okay, some of these are also just called whole numbers. Let's draw the box for that group. These are all whole numbers. Let me move that 0. Okay, so whole numbers would be 0, 1, 2, 3, 4, 5, 6, on up like that. Whole numbers don't include the negatives, so that's why these negatives are outside in this integers box. All right, now this 2 and the 4 here, those are whole numbers, but they also belong in a further specialized subgroup. So let's draw another box in here. Okay, let me move those a little bit. These are your natural numbers. Some people call this group the counting numbers. So what numbers do you use to count? 1, 2, 3, 4, 5. It's the same as these, but when we count, we don't start with 0. So 0 belongs in the whole number group, but all of the other numbers in the whole number group belong in this natural group also. So all of your natural numbers are whole numbers. That's why that's inside this box. All of your whole numbers and natural numbers are integers. That's why they're inside this box. And all of your integers, whole numbers, and naturals, those are all rational numbers. Okay? So to review, rational numbers are anything that can be written as a fraction. Okay? So this could be written as -3/1, 0/1, 2/1. That's that ratio with the fraction bar in there. They can all be written as a fraction, so they're all rational numbers. Irrational numbers cannot be written as a fraction because they will have that non-terminating, right, it'll go on forever, decimal that doesn't repeat. Okay, so if we have a number, let's switch colors here. What if you had to classify this square root of 16? Where would that go? Well, the square root of 16 isn't irrational. We can actually answer that question. It's 4. Well, 4 is a natural number, which is also a whole number, an integer, and a rational. But because we know 4 is a natural number, we can put that in there. So we can actually put square root of 16 as counting as a natural number, because once you simplify that, it would just be 4. What if you had 3.3 repeating? That 3 goes on forever, but that doesn't make it an irrational because it's repeating. It's got that bar over top of it. Okay, so where would this go? It would go in here. Okay, it has this decimal bit on there, so it won't fit in these boxes. But it is a rational number. So how would we write this as a fraction? This is 3 1/3. Or if you wanted to look at it as an improper fraction, it would be 10/3 as a ratio. Okay, so real number system, rational and irrational numbers. Rationals can be written as a fraction. Irrational numbers go on forever, don't repeat. Okay? And then we have these subsections in here as part of our rational numbers. I hope that helped clear some questions up for you and will help you when you get to this in school or if you have to look at it on your homework again. If you have any other questions, ask me in the comments. Thank you for watching.